Okay, today we're going to be looking at solving equations with logarithms. So if we consider the equation, let's look at log base a y equals x. We would just consider that to be an example of a general logarithmic equation. We can rearrange this and work with this in a number of different ways. I'm going to go over those ways now. So let's look at our first couple of examples. First one's pretty straightforward. If I had log base 2 x equals 3, pretty simple what we need to do with this one. We just need to rearrange it into index form, which we are pretty good at. So we have log base 2 is going to be our base to the power of 3, and it's going to equal x. So we're essentially asking what is 2 to the power of 3, and it's going to equal 8. So you'll notice, just like logarithmic equations, like any other equation, we're pretty much just trying to find out a value for x. And if we look at or if we remember back to our general logarithmic equation, log base 2 y equals x, we're just trying to find the value of x. So here we've been able to do so, no dramas at all. So next one, let's look at log with base of 6x equals -2. This one's a little bit more complex, but not too bad. First things first, we're going to rearrange it into our index notation. So we have a base 6 to the power of -2 is going to equal x. So we have something that's going to be a negative power, so I'm going to put my x here. So we know it's going to be 1 over something because we've got a negative power over here. So I'm just going to rewrite this as 1 over 6 squared becomes 1 over 36, and that's going to be my answer. Nice and simple. And last example on questions of this nature. Actually, let's do 2 more. So let's go log base 3 x to the power of 4 equals -16. Now, using our third logarithm law, we know that we can take this x to the power of 4. We have to take this 4 out the front and multiply this whole log. So 4 log 3x, like that. All I've done is taken the 4 at the front. We know we can do this from our log law 3. Look at the last video for log laws if you need to. Now, this is saying 4 times log base 3x. So because it's 4 times, if I was to do the opposite on the other side, I would divide this side by 4, divide this side by 4 to get rid of it as well. So I end up with -4 on this side, and I still have log base 3 of x. Now we have something in the general equation form, so let's turn this into index form. So I have log base 3 to the power of -4 is going to equal x, pretty straightforward. So I want this to become not a negative, so I can put 3 over 4 under 1, x equals that, and 3 to the power of 4, centered right up here. So I end up with x equals 1 over 81. Pretty straightforward stuff. And my last example, gotta learn to do that faster. So if I had log with the base 5x minus 1 equals 2, well, there's nothing really different about this. We just have to evaluate this as we would any of the others. And that starts by converting it to index form. So I'm going to say 5 to the power of 2 is going to equal x minus 1. We know 5 squared is going to be 25, equal x minus 1. We want to get rid of the 1 on this side, so we plus 1 here and we plus 1 there. Therefore, my x is going to equal 26. Pretty straightforward stuff there. Nothing too fancy. Now, our next example that we have is a little bit more wordy, so I'm going to write the words. That's ocean. Enjoy the ocean. All right, so This example here is going to say solve for x in log base x 25 equals 2, given that x is greater than 0. This is going to be an important part here that we really need to consider. So let's solve this like we would any other. So I'll start out by just rewriting my equation here. So I have log base x 25 equals 2. I'm going to write that in index form. So I have x to the power of 2 is going to equal 25. So we have to ask ourselves, well, x to the power of what equals 25? So we all, probably the first thing we jumped at would have been 5. And if we check, is 5 greater than 0? It is. Well, this satisfies our requirement up here. But the reason it asks is, if I'd switch this around and said x is less than 0, well, we know that there's something else that makes 25 that you square, and that could be -5 times -5. Okay, so our answer here could be -5. It all depends on what it asks us to do up here. So we need to be really careful with that when we get these kind of questions when we're dealing with logarithms. Okay, on to the next one. Okay, so a few more examples here. Nothing too crazy yet. So if I had log with base 2, 16 equals x, just like anything else, we're going to write this in index form. So we're saying 2 to the power of x is going to equal 16. So what do we know? 2 times 2 times 2 times 2, so that's 2 to the power of, to make that true, I need to change the value of my x to a 4. So that means that my x is going to be 4. Pretty straightforward stuff. Next one. So let's have a look at, oh, this one gets a little bit trickier. So I have log base 3 of 1/3 equals x. How are we going to approach this one? Well, it's not as bad as you think it is. So I'm going to rewrite this in index form, just as we usually would. 3 to the power of x is going to equal 1/3. What do we know about something that becomes 1 over something else? It means we're going to have a negative power here. So the easiest way to think about this is, well, I'm just going to ignore this top number here for now. I'm going to say 3 to the power of what is going to equal 3. Well, I know 3 to the power of 1 is going to equal 3. But because we have 1 over whatever it is here, it's a really big giveaway that this needs to become a negative here. So x to the power of -1. So it's tricky to think about, but essentially we need to create equivalence between these two things, because that is going to become that. So we essentially need to find a way to turn this 3 into 1 on 3. The only way to do that is take it to the power of -1, which is what we've done there. All right, next example. So let's have a look at log base 9 3. Log base 9 3 equals x. Well, this one's a little bit trickier. I kind of wish I gave myself more room, but here we go. Let's rewrite this in index form. We have log base 9 to the power of x is going to equal 3. So see, whatever it's going to equal is actually smaller than our number that we have attached to our power. That's a really dead giveaway, but it's probably going to be a fraction. It's going to have to be a fraction, pretty much. How do we come to that conclusion? Well, what we're doing is, okay, we're going to work with base 3. Somehow we got to a 3. So I'm going to rewrite this 9 here as a base 3 number. So instead of writing 9, I'm going to change it to a 3 squared to the power of x, and that's going to equal 3. Well, what do we know with that index loss here? Well, we know that 3 becomes to the power of 2x, and that's going to equal 3. But, well, what is it 3 to the power of? Pretty easy, 3 to the power of 1. Okay, it's just a little, 3 to the power of 1 is 3. Now that we have the same base, we can actually ignore them and just have our statement of equivalence between whatever our two powers are. So it becomes 2x equals 1. So 2 times x, therefore I divide that side by 2, divide this side by 2. So x becomes 1/2. So as I predicted, it's actually become a fraction because this number, the right-hand side that isn't associated with the power straight away, is smaller than the number out the front. Just a couple more examples. Okay, what else have we got? Alright, this one says solve for x in the equation log base 2 4 plus log base 2x minus log base 2 8 equals 3. Now this is a pretty scary looking one, but it's not actually that bad. I'm going to ignore the fact that it's equaling anything right now. I'm going to ignore the fact that there is a statement of equivalence. I don't care about that right now. I'm going to think about what I know about my log laws. So I know if I'm adding two logarithms of the same base together, I actually multiply whatever is on the end of the logarithms. And I know if I'm minusing, so I divide by whatever's on the end of those logarithms. So I'm going to rewrite this section here just using my log laws. So I'm going to say log base 2, because they all are base 2. I do it all in one step. I'm going to say, well, if we have a look, what is it? 4 times x, based on our log law 1, log law 2, divided by, because I'm minusing, 8, and it's going to equal 3. This ends up being log base 2 4x over 8 equaling 3. Pretty straightforward. So if I do my, if I work this one out here, it ends up being log base 2, so divide both by 4 here, becomes x on 2 here equaling 3. Now, this looks like something I can work with. So I'm going to rewrite this here in my index form. So I'm going to take my base 2 to the power of 3, and that equal x on 2. I'm just going to take my equation up here. So 2 to the power of 3. Well, 2 2s are 4, 2 4s are 8, and that's x on 2. Now I need to get rid of that x or that 2 on the bottom of x on 2, so I'm dividing by 2, so it's times by 2. That becomes 8 times 2 on the left hand side, going to equal x, therefore x is going to equal 16. This one looks messy from the outset because of all these operations you need to do here, but if you just take it one step at a time, it's quite easy to get yourself into your general logarithmic equation form and then solve for x from there. Just a quick note, you may get some questions that look a little bit like, let me just find my example here. May get some questions that look a little bit like log base 2 x plus log base 2 of 4 equals log base 2 of 20. You might think, well, what am I going to do here? I can't really solve that because I don't have a number on the other side. Well, you kind of do. So if we think about our log laws, let's just deal with this first. This is going to be log base 2 of x times 4 equals log base 2 of 20. So it's going to be log base 2 of 4x is log base 2 of 20. Now if we look here, I have log base 2, log base 2. I'm dealing with the same thing. Okay, I have the same base essentially. So I can actually ignore those for now and just solve for x by saying 4x equals 20. And if I did 20 divided by 4, x is going to equal 5. 4 5s are 20. Yep, that's it. Okay, so we can actually just do here and ignore the logs at the front once we actually get there, because it's essentially saying we're working with the same base. Okay. And our last type of question is going to be, I'll do two more. So if I had 2 to the power of x equals 7, and I was asked to solve that. This is messy, because nothing 2 to the power of something doesn't equal 7. Nothing even, nothing neat. They'll probably ask you to solve it to 2 decimal places or something like that. But what we can do is we're using a base 10 number system. That's because we have 10 fingers, and when humans started counting, we use 10. So every time we get to 10, we add 1 to the column in front to signify that we've counted 10 once, and then we start again. So we're going to actually use base 10 as our default logarithm. We know by using the logarithm, we can deal with our exponents and our powers. Same deal as we've always been doing. So what I'm going to do is, I'm just going to rewrite this here as log base 10, 2 to the power of x. Pretty straightforward. It's going to equal log of base 10 again to the power of 7. Now we have two logarithms. We can work with this. We know from our third law that I can move my x out the front here. So log base 10 of 2 equals again log base 10 of 7. So I essentially have x times log base 10 of 2 equals log base 10 of 7. So if I have times, it means I can I can divide, do the opposite on here over to the other side. So that means, so therefore, x is actually going to be log base 10 of 7 divided by log base 10 of 2. Now this is something you have to do in your calculator. Your calculator will automatically default to log base 10. So if you hit log, and then the brackets wrote 7, close the brackets divided by log in brackets 2, and did that, you would get the right answer coming out. So if I was to do that in the calculator there, it equals 2.807 to 3 decimal places. The last one, which is pretty similar to that again, well, it's almost exactly the same, we're looking at a negative number instead, is 3 to the power of negative x and equals 0.4. Again, not very nice numbers to work with. Instantly, I know, okay, this doesn't make any sense to me. So I'm going to take log of base 10, 3 to the negative x, and let it equal log the base 10 of 0.4. Again, I'm going to take my negative x down the front. So that's just a 3 log base 10, 0.4. So my negative x, I'm going to divide this one over, is going to equal log base 10, 0.4 divided by log base 10, 3. And actually equals negative x. It's still a negative. I'm still taking my negative down. It's going to equal negative 0.834. Because I have negative x equals negative that must mean that positive x is going to equal 0.834. And that there is pretty much all your logarithmic equations in a nutshell. All the different kinds that get thrown at you. Yes, the big trend is typically to get it in the logarithmic general equation form. So log base a of y equals x. And if you have any nonsense around it, you just want to get it back to that form so you can then solve the logarithm from there. Pretty straightforward. Hope it helps.